Hello, my name is Oleg Fafurin, and I'm an intern in the Indexes team. This summer, I was working on a project named Index Viewer plugin under the mentorship of Dmitry Betkovich. Let's start with explaining what indexes are. You can think of them as some meta information related to files. For instance, a file type, or if it's a source code file, the names of the methods defined in it. Such information is represented by a key-value map for a specific index. And when the IDE starts up, internal machinery builds many indexes by invoking their indexers on files needed. Then this index is transformed into a so-called inverted index, where you can retrieve both values and corresponding files by a specific key. Such indexes are a basis for IDE smart features, code navigation, completion, and highlighting, for example. But those indexes are stored in a binary format on disk that makes it hard for a developer to analyze their content. For this purpose, the Index Viewer plugin was introduced a couple of years ago on JetBrains hackathon. It supported viewing certain types of indexes in an IDE editor, and I believe most of you are familiar with such a view. It has the same structure as a debugger view in IntelliJ-based IDEs. And the rest of the presentation is about features I implemented this summer. Let's start with a small yet quite useful change. Index Viewer plugin allows its users to run a few inspections on indexes to make developers' custom-built indexes more efficient. I've added an inspection results window and a couple of new inspections. One is to detect numbers stored in string format. Unfortunately, yes, some people try to do so. And another inspection is about using long when integers are enough. Using such formats prevents us from storing this index efficiently because numbers can be stored in a more compact way, and therefore data retrieval could be done faster. The next implemented feature description requires a quick introduction. When a project file is parsed, the nodes of the results in parse tree are called PSIs. Abbreviation stands for Project Structure Interface. But the whole parse tree is quite a heavy structure. Stub is a subset of the parse tree containing the nodes important for smart IDE functionality. Examples of these nodes are methods or class declarations. Stub indexes map keys to these stub entries within a specified file. They are essential to smart IDE features mentioned above, highlighting, completion, so very useful thing. And on the picture, you can see a newly implemented Stub index editor view with files on the first level and different indexes available for those files on the second. And on the lower level, you can see index keys and the Stub entries corresponding to them. I've also added another relevant inspections to highlight the files which shouldn't contain Stub at all, for example, directories. And by that reason, no Stub indexes are expected for them, but somehow they exist. And this feature can help JetBrains Indices team to investigate possible issues related to our internal indexing machinery, as well as help third-party developers to distinguish their errors from the platform errors and to analyze their errors only. Another feature I implemented was show index for a file, which has quite a self-explanatory name. And it retrieves all the indexes that have some data for a specific file and opens them in an editor as usual. And the last feature I implemented was the remote index viewing. It requires a plugin installed in the IDEs on both remote and the viewer machines. On the remote machine, you should launch an index server to let others connect. And on a remote machine, you can then connect to this server using its address and port. Well, and then after a successful connection, you can choose the indexes needed to fetch and view them in an editor as usual. This feature is based on gRPC framework, which allows you to interchange data using the user-defined format between machines efficiently in a binary form.